Hi guys, I want to talk about atmospheric refraction and the conventional explanation of why atmospheric refraction does not work on a convex ball planet Earth. There is a little bit of problem here with what they explain to you why atmospheric refraction is working. They will say it actually warm air will bend up away from you, and that's actually what is happening where it's bending up away from us. The sunlight, the air, it's bending up away from us, and therefore it is refracting, and it's also aided by a glass sky, but they don't say that. But this is their standard definition, explanation. Let me get a screen cap.
The ray of light will reach the observer at O, as if it had come in the direction AO instead of in its true direction BO. Consequently, we do not see the true position of the sun. It is due to atmospheric refraction that the sun is visible before actual sunrise and after actual sunset. Do you know this fact? The sun appears to rise 2 minutes before the actual rise, and it continues to be seen 2 minutes after it has actually set.
Okay, stop right there. This guy's saying that the sun appears to rise 2 minutes before the actual rise and continues to be seen 2 minutes after it has actually set. On a convex planet with the warm air bending up away from you, not toward you, this is in direct violation of what they say is happening here, okay? It should not be bending down toward the Earth. It should be bending up away from the Earth. So what I did is just simulated here in Lightwave a little test to show you what would happen if the refraction were happening on a convex planet. And basically what I do is I just added a little glass sphere over the convex Earth, and then I compared the two, and you're gonna get, let me get this up here. Okay, on the left side you see the sun rising without refraction on a convex planet, and on the right side you see the refraction happening because I turned it on. So it's the same. I mean, the angle of the sun is actually the exact same. It's not, the geometry has not changed. It's just the refraction added. That's the difference. So if I press play there, you see that the sun is rising slower on the right with the side with refraction. Therefore, on a convex planet with light bending up away from the observer, this would not. This would be what would happen. What would be happening? So the sun would be late, basically. See, if you look at the blue on the bottom here, it's the same value, even though the height of the sun is different. So basically, what would be happening if we were on a convex planet and there were refraction happening? The sun would be slower, and we would experience sunrise before we actually saw the sun, not after, like they say. They say that we experience sunrise after we see the sun, but it's the actual opposite. You understand what I'm saying? So, the truth of the matter is that we're inside the concave Earth and light is definitely bending. There is refraction going on, and the main reason why we see the sun before we actually experience sunrise is because of the refraction going the other way, and it also is aided, I believe, by the glass sky. If you watch this little video here I did before, you see how the sun rises like that inside a concave glass sphere. So it's rising, okay, plus the bending light. So that is really why we see the sun before we actually experience sunrise. It's the exact opposite. They totally contradict themselves. Thanks for watching.
in this cave,